We're talking about constant rates of change, and that is exactly what it sounds like. It's how much everything is changing and if it's constant or not. So in 7th grade, we talk about linear functions. Now, linear means a straight line. So if that line is straight, that means it's going to have a constant rate of change. So let's look here at the x values of the first table. X goes from 1 to 3 to 9 to 5. So we're going to see how much this is changing. And the same thing with the y values. They go from 2 to 6 to 18 to 10. So we want to make sure that it's following a constant pattern. All right, so let's look at these x values here. X goes from 1 to 3. So what it's doing here is it's adding 2. And we're always looking at addition and subtraction here. So if the first and second value is going plus 2, then down at the bottom, we're going the y values from 2 to 6. So it is adding 4. So every time it adds 2 on the top, it should add 4 on the bottom. And if you wanted to simplify, that means for every 1, the x values change, the y values should change too. All right, so let's do the next one. From 3 to 9, it is adding 6. For the y values, 6 to 18 is adding 12. So if we look at 6 and 12, if you simplify that down, that would also be for every 1 x is changing, the y's would be changing too. All right, for the next x values, it's going from 9 to 5, so it is subtracting 4. Down on the y values, it's going from 18 to 10, so it's subtracting 8. Again, for every 1 that the x is changing, the y is changing too. So that's how you know it's got a constant rate of change. Okay, the constant rate of change here would be 1/2. Right, that's also the unit rate. Later we're going to talk about slope. It's also the slope. So all three of those things mean the same thing. That's the constant rate of change. For every 1x, the y is going to change too. All right, let's look at this next table over here on the right. We're going to do the same thing. So x is going from 2 to 4, which means that it's adding 2. All right, our y values are going from 6 to 12, so it is adding 6. It means for every 2 that the x changes, the y changes 6. Now again, we could simplify that down. Every 1 the x is changing, the y is going to change 3. So let's check our next values. It's going from 4 to 8, so it's adding 4. Down on the y's, 12 to 24 is adding 12. So if we simplify that down, that would be 2 and 6, or 1 and 3. So these two are the same so far. All right, checking the next one. From 8 to 6, it is subtracting 2. And from 24 to 21, it is subtracting 3. All right, so notice here that we're not having the same kind of pattern, right? 2 and 6 simplifies to 1 and 3. 4 and 12 simplifies to 1 and 3. But 2 and 3 does not simplify to 1 and 3. So this one will not have a constant rate of change. If we graphed it, it wouldn't make a straight line. All right, I wanted to show you this table. Sorry I had to create it myself, but I wanted to show you something. Here on the first table, you can see that it's 1/2, 1/2, 1/2, and 1/2, just by looking at the x's and the y's. Okay, same thing on the next table. It was 1/3, 1/3, 1/3, and then not 1/3. So I wanted to show you that it doesn't have to be that way. Okay, here, from 0 to 1 is adding 1. On the bottom, from 1 to 2 is adding 1. So we know every time the x adds 1, the bottom, the y's should also add 1. Okay, so same thing here. We're adding 1. On the y's, we're adding 1. So even though this is 0 over 1, and then 1/2, and then 2/3, that's not what the constant rate of change is, right? The constant rate of change would be 1 over 1, or 1. Since the constant rate of change here is 1, because every 1 the x goes up, the y is also going to go up 1. So I just wanted to show you the difference between the tables there. You're just looking to see how much the x is changing and how much the y is changing, and if that's constant throughout the table. And that's how you find constant rates of change.